we continue review for calculus 2. In this part of the review, we will integrate the trigonometric function or the product of sine, cosine, secant, or tangent. The most important, when we write the power like that, we mean sine up. We do the trig function first. Actually it should be like this, and then the power will be for the whole trig function. So right, now let's go over the rule for that. It's over there. Right, so for sine and cosine together, whatever function has the odd power, we will let u equal to the other one. Now the odd power is on the sine, so we'll let u be cosine. So we start with that. We know that's what the substitution is going to be. So we let u equal to cosine, because the odd power is on the sine, so u is going to be cosine. And this has a 7x, so we say cosine of 7x. Right. And even though there's no cosine there, but worry about that later. Right. And then this one has the limit, so we should change the limit to u as well. Right, we'll take the derivative of cosine is negative sine, and there's a 7x, so that would be negative 7 sine of 7x. I'll move the dx over. And then divided by negative 7. Right, so we solve for the x. We have u and dx. Right. And then the limit, x go from 0 to pi over 7. I don't have space here, so I'm just going to draw a table like this instead. We have x, and then u is equal to cosine 7x. When x equal to pi over 7, and when x equal to 0. When x equal to 0, cosine of 0 is equal to 1. And pi over 7, substitute in here, 7 and 7 cancel out cosine of pi. Cosine of pi is negative 1. Right, so we have the change of limit as that. Right, now it's ready for the substitution. So now the limit, it will change from x from 0 to pi over 7 to negative 1 to negative 1. And then we still have sine of 7x cubed. If we want to, we can just write sine of 7x cubed like this. Yeah, the cube go to sine like that. The x, I'm going to use this one. Du negative 7 sine of 7x. Right. Sine of 7x cancel, we have 2 of them left. The negative 7, bring it outside, stay at the bottom. And then du, so we'll have negative 7 from 1 to negative 1. And then sine square, just put 1 on the top. This is square here. You can write sine square. It doesn't matter. And then sine cancel out. -7 coming out. Just du. Right, so it's good. The only problem here is it must be in terms of u. So here we have sine square, and the relation between sine and cosine, we have the identity cosine square plus sine square is 1. So sine square is 1 minus cosine square. (1/7) from 1 to -1. Right, sine square is 1 minus cosine square. So this is 1 minus cosine square of 7x. Right, now u is cosine square, so that is u. It is just 1 minus u square du. Right. Now the rest will be simple. That's an even function from 1 to -1, so we're just going to double that if we want to. But first, let's do this. There's a negative sign. If we want to take that away, we can interchange the limit. So the 1 go there, -1 go there, and take out the negative sign. So that's 1/7 from -1 to 1. 1 minus u square du. Right, so we have 1/7. The integral of that is u minus u cubed over 3. Going from -1 to 1. So 1/7. Now put 1 in here. Minus 1/7. Put -1 here. After all of that, we have 1/7. 1 minus 1/3 is 2/3. So 2/21. And minus 1 plus 1/3. So minus 2/3. So that plus minus -2/27. 21, sorry. And that 4/21. Right. Now this is a definite integral, so we should check the answer. Make sure it's in the radian mode. Yep. Go from 0 to pi/7. And we have sine of 7x cubed. Right, can we change to fraction? Yep, so that's what we have. Right, next, for this one we have the power of cosine is odd, so in that case u is going to be the sine. Right, so whatever all power on, we let u be the order function. Now this is cosine of 2x, sine of 2x, so we let u equal to sine of 2x. Right, take the derivative. Forgot the timestamp. Derivative of sine of 2x is going to be cosine of 2x, and then derivative of 2x is going to be 2. Right, move the dx. And divide the 2 cosine over right, so we have u and we have dx. This one does not have the limit, so just an integral, so we not need to change the limits. Right, is equal to sine square here, that is u, so u square. And then cosine, I'm just going to write cosine. And dx is this. Right. So I can cancel 2 of them. I mean, one of them, there's 2 left. And there's a 2 here. Take it outside. And that will stay at the bottom. Right, so there's u square. And then the cosine square up to x. And the 2 and the cosine, that's gone. There's only du left. Right. Next we use the Pythagorean identity. Cosine square plus sine square is 1. So cosine square is 1 minus sine square. This is u square. This is 1 minus sine square. And sine square is u square. Right, multiply it out. U square minus u to the 4th du, and integral will be 1/2 u cubed over 3 u to the 5th over 5, and then plus a constant c. And at the end, all we need to do is substitute back u is sine of 2x, so we just gonna write this 1/2 sine of 2x cubed over 3 minus sine to the 5th of 2x over 5 plus c. Right. So as you see, the rule over there is very clear. Whatever the third the cube power, I mean an odd power on whatever function is, we will let u be the order function. Right. Whatever the odd power is on a function, let u be the order function. Now, unless of course when all of them are even. So if it is even, and we say if it is even, we use power reducing identity, and the power reducing is here. Right. So this one we have to use power reducing. So first, divide the page into 2 because that might be a long problem. Right, power reducing. Notice that we have a sine square, so we're going to use that for sine square. But before we write the sine square, I'm just going to write sine square and then square again. Right, now power reducing for sine square is 1 minus cosine of 2x over 2, and we square that. And when we square this, the square goes to the top, the square goes to the bottom. Square goes to the bottom. So, and the bottom is 2 square. So we multiply 2 square is 4, bring it outside. At the bottom is 4. Right? And then we just have 1 minus cosine of 2x. A square is multiplied by itself. Right? Multiply it out. 1 minus cosine of 2x minus cosine of 2x and plus cosine of 2x square. Combine like terms. So that's one easy, that's one easy. The cosine square here, that is another power reducing. So power reducing for this one. Right. Cosine square is 1 plus cosine of 2x. I mean, power reducing, as you see, the angle is going to be double the power is reduced. So we have to have 2 times 2x. So the angle is going to be double from 2x to 4x. Divide by 2. Right. This one I'm going to split. That is plus 1/2 and plus 1/2 here. Right. So we continue. 1/4 integral 1 minus 2 cosine of 2x plus 1/2 and plus 1/2 cosine of 4x dx. 1 and 1/2, that 3 halves. Right? got the integral minus 2 cosine of 2x plus 1/2 cosine of 4x right. The rest is easy. 1/4 integral of 3/2 is 3/2 times x. Integral of cosine is positive sign, but this has the 2, so we have 1/2 sine of 2x. Integral of cosine is sine, but there's a 4, so divide by 4. Sine of 4x plus c. Right. Right, so that is 1/4 3/2x. 2 and 1/2 cancel out. 1/2 and 1/4 times together, well, that's 1/8 sine of 4x. Of course, we can multiply the 1/4 out, but that is good enough. Right, we continue. On this one is not on test. I'm just going to throw it here. If we see something like this, there's a trig identity where we have the product of sine cosine, so it's going to be that identity. So it's very simple. Once we know the identity, sine times cosine is 1/2 sine of a minus b, 5x minus 2x, plus 1/2 sine of a plus b, 5x plus 2x. So 1/2 sine of 3x plus 1/2 sine of 7x. And integral of sine is negative cosine, and there's a 3, so negative 1/3 cosine of 3x. It's divided by 7, and that's integral of sine is negative cosine. So that's negative 1/6 cosine of 3x minus 1/14 cosine of 7x. Let's see. Right, times 10. Right, so that is the integral involves sine and cosine. Now the integral will involve secant and cosecant. So the rule is if the power of secant is even, then u is tangent. If the power of tangent is odd, then u is equal to secant. And in other case, then we have to use Pythagorean identity, and there might be some trickery to go with that. Right, so now we have the power of secant is even, so u is equal to tangent. Right, now this is just x, so we're just going to say u is equal to tangent of x. So we say power of secant is even. So u equal to tangent. Here just tangent of x. And we take the derivative and solve for dx. So that's exactly like what we have been doing. Derivative of tangent is secant square move the dx. And divide by the secant square. Now secant to the fourth power of x dx is that. Again, we don't even have tangent here, but don't worry, the rule is very clear. The tangent will show up later. The rules for this is very clear. Now the secant square cancel with the 4 of them, so there will be 2 left. The 6 here can just bring it outside. And then secant square. Right, that's 6. Secant square du, that cancel out. Right, now we have the secant square. Secant square, the identity is secant square equal to tangent square plus 1. It's not there, but you need to know that. So tangent square plus 1 is secant square. So this is just tangent square plus 1. And you said, is that integral of secant square is tangent? Yes, but remember this is x and this u. We cannot integrate where the variable are not the same yet. So we have to rewrite this. Secant square is 1, tangent square plus 1. And then u is tangent of x, so that is u square plus 1 du, and the rest is easy. 6 u to the 4th, sorry, integral of that is u cubed over 3 plus u plus c. And finally, u is tangent of x. And u is tangent of x plus c. So that's what we have. So if the power of secant is even, u equal to tangent. And even though it's not there, it will show up eventually by the Pythagorean identity. Right. Right. Next we have tangent to the 4th equal to 6t. Right. So power of secant is even. That is a substitution. Power of tangent is odd. That is the substitution. This one is either. So when we have the tangent is even, that means we have to use Pythagorean identity here. Right, we'll see what happened after that. Okay. Pythagorean identity. So first, this is the Pythagorean identity. Tangent square is 1 plus secant square. So this is going to be secant square minus 1. Right? Let's write out tangent. I'm just going to say theta because the angle is not x or t. It's 60. Right? Tangent square plus 1 is secant square. So tangent square is equal secant square minus 1. So we'll write first as a tangent square and then square again. Right, and the tangent square is secant square minus 1. So that is tangent square, and then we still have a square here. Right. Now, just square this by multiply by itself. Secant square of 60 minus 1 times itself. Secant square times secant square, secant to the 4th minus secant 60 minus a square minus secant square of 60 minus 1 plus 1 dt. So that to the 4th and then 2 of them and plus 1. Right. So we said, how does that help? First of all, we don't do any substitution here yet or at all. So integral of 1 is just going to be t. Integral of secant square. Integral of secant square is just going to be tangent. And then the secant to the 4th. Well, we just did that. Except this one has the 6. So if we take out the 6 from the beginning, we take out the 6 at the bottom. So that is integral of x secant to the 6. I'm sorry, secant to the 4th power. It's going to be that. Right? So pretty much we have everything. Right. Now, let's just split this in 3. Secant to the 4th 60 dt minus 2 secant square 60 dt and integral of dt. Right, now the first one, again, because of the 6 in the beginning, the 6 at the end, I'll just take them out. So that is the integral of secant to the 4th. And now, so I'm just going to say it. For this integral, it is going to be tangent to the 3rd of 60 over 3 plus tangent of 60. Now there's a problem here. there's a 6 here, whereas here we don't have it. Now just like any integral, the integral of sine of 3x is cosine of 2x and then divide by 3. It happens to be negative. So if there's a 3, we divide by 3. Now if there's a 6, we do divide by 6. Right, so that is that. Next, integral of secant square over there is tangent. Again, there's a 6 here in the way, so we have to divide by 6. And that will be just tangent. And then this is just plus t plus c. Right. Simplify this. We have 1 over 18 tangent cube plus 1 over 6 tangent of 6t, and that is 1 over 3, or 1/6 minus 1/3. And then finally we just combine like terms. 1/6 minus 1/3 is negative 1/6. So the whole thing together is negative 1/6t, but wait, that will be good enough. Right. So on this one, because the power of secant is not even, and the power of tangent is not odd, we have to use Pythagorean identity. Just work out to be, turn out to be something nice, and nice in the sense that this gives us secant to the 4th, which we just did earlier. Now secant cube and tangent cube. Right. If power of tangent is odd, split one secant tangent and then let u be secant of x. Right. So that is u equal to secant of x. And then take the derivative and substitute in for dx. Secant tangent move to dx, and divide by that. Right. Now, we let u equal to secant of x. If we're going to let u be that one, now, because we have secant x and tangent x to cancel out, so if we let that equal to u, well, we don't have the secant to cancel out. So that's why in here we said we split tangent x and the secant x like that, and the rest they'll determine later. Okay, so actually, because we're going to need the secant x to cancel with the secant x at the bottom, I will not write secant x here as a u yet, right? So just going to write secant cube and tangent cube. The dx, now I substitute in du over secant x tangent x. As you see, we need the secant x there to cancel, so that's why I do not write as u. Right, tangent x cancel out, there's 2 left. Secant x cancel out, there's 2 left. So we have secant square, tangent square, du. Right, only then we can substitute into secant square. Here is the u. Now that's good to know, but we still have the tangent here. I mean, tangent is not a problem. The problem is we have x here. So if everything in terms of u, that would be good. So we use the identity. Tangent square plus 1 is secant square. So tangent square, secant square minus 1. So u square, tangent square is secant square minus 1. And the secant is going to be u, so that is u square. And multiply them out, u to the 4th minus u square du. So u to the 5th over 5 minus u cubed over 3. And finally, secant is u. So secant to the 5th minus secant square. Right. So that's what we have. Right. So that is the trigonometric integral. Next we will have the trigonometric substitution. So if we have a constant square, it's over there. If we have a constant square minus variable square, that is sine. If we have a constant square plus a variable square, that is the tangent. If we have a variable square minus a constant square, that is the secant. So on this one, this is going to be a sine. Right, I will rewrite this as follows. From 0 to 1, I prefer to put the dx at the back, and 81 I can write 9 square. Right, now the substitution. It's not a u substitution. Right, a variable square, I mean constant square minus variable square. So let the variable be 9 sine of x. Or I take derivative because it's not x, it's something else. Right, take derivative. Nine cosine theta and dx is 9 cosine theta d theta. Right, that's good. For the substitution. Well, this one has the limit, so we do need to take care of the limit. Let's make a table for that instead. There's x. Actually, we go to d theta, so we need to find the limit for theta. Right. So, worry about. Actually, we're going to just keep the limit for x. So we say x equal to 0 and x equal to 1. So we know that limit is still x, even though we have d theta here. So be careful with this type of problem. Of course, we can solve for that with no problem. Yeah. In this case, if we want to solve for theta, we have to take sine inverse and x over 9. And the limit will be very complicated. So that is sine inverse of 1 over 9, and I don't want to mess the limit that much. Yeah, even though we have theta here, but the limit is still x. So I write like that, so we won't forget that at the end. Right, so substitute for x, and the x is this. Right, now inside the parentheses, inside square root, there's a 9 square I factor out, and then 1 minus sine square. Right, so that gives us 9 square and sine square. Factor out the 9 square. This is what we have. So square root of that just 9. 1 minus sine square, that is cosine square. I just do that for a moment. Right. Still have 0 and 1. Right, square root, undo the square, undo the square root. So that will be just 9 cosine of theta and 9 cosine of theta d theta. Oh, that cancels out nicely. Yeah, cancel everything. And so that just gives us theta. Integral of d theta, just theta, going from x equal to 0 to x equal to 1. Right, now this is theta. Yeah, so if we have to write in terms of x, so we can use this. It's not that bad. If this is x, x over 9 is equal to sine theta. I will write this over here. X equals 9 sine theta. So x over 9 is sine theta. So theta is sine inverse of x over 9. So sine inverse of x over 9 going from 0 to 1. So sine inverse of 1 over 9 minus sine inverse of 0. Sine inverse of 0 is 0. Okay, radian mode. Sine inverse of 0 is 0. So we just have sine inverse of 1 over 9. Right. Sine inverse of 1 over 9 is that much. How about the integral? Right, we should get the same thing. Right, so that is the variable square. I mean the constant square minus the variable square, so that is sine. This one. By the way, if we look at the formula for the integral, yeah, we do have that sine inverse. Right. On this one, we still have a constant square minus a variable square. Okay. 6 square minus variable square. So in that case, we let u equal to 6 sine x, sine theta, that is. Let x be 6 sine of theta. Alright, we'll take derivative. It will be 6 cosine theta. Move the d theta. Right. Usually this problem involves to solve back in terms of x, so I'm just going to leave the space here. We might need to draw a triangle and do some other things to solve for, but we continue the integral from here. Be 6 square. X is 6 sine theta. Square. Dx is 6 cosine theta. D theta. Right. Square root. This gives us 6 square minus 6 square sine square. And then there's 6 cosine theta d theta. Right, sorry about the right out space at the end there. But that's what we have. Right. Of course we can factor out the 6. But we should factor out the 6 square here. And 1 minus sine square. And then there's still 6 cosine. Right. 1 minus sine square here is going to be cosine square. square root cancel the square here, so we have 6 cosine theta, and then 6 cosine theta d theta. So that gives us 36 cosine square d theta. Take out the 36. Now, cosine square. Now, how do we integrate cosine square? Now, this brings us back to where the integral of sine and cosine. If the power of sine cosine even, then use the power reducing identity. So power reducing for cosine square is this. So cosine square using power reducing, 1 plus cosine of 2 theta over 2 and then d theta. Right, take the 2 outside. At the bottom, 36 over 2. It's fine, let's just write 36 over 2 for now. Alright, and that gives us 1 plus cosine of 2 theta d theta. Alright, integral of this, by the way, 32 over 2 is 18. Integral of 1 is theta. Integral of cosine 2 theta is 1/2 sine theta cosine theta. Right? Sorry, I'm one step ahead. Integral cosine is going to be sine. Right? That cause double angle will come later. Right. Now actually the power reducing next to it is the double angle. So 1/2 of sine 2 theta is still going to be sine times cosine. Right? Formula's over there. Yeah. Integral cosine is 1 over integral cosine is positive sine, and there's a 2, so that's why we have to divide by 2, and just so that 1/2 of sine 2 theta is equal to sine times cosine. Right, so we have to turn everything in terms of x. So we have to solve for theta, sine theta, cosine theta. Right, now when we have this, we can say sine of theta is x over 6. So we do have sine of theta here. Also from here we can say theta is sine inverse of x over 6. So for that we have this theta. The only thing left to be determined is cosine of theta. Right? So we use the raw triangle for that. Sine is opposite of hypotenuse. So this is 6 square minus x square, square root of that, which is square root of, the adjacent is 36 minus x square. And we need cosine, so cosine is adjacent over hypotenuse of 6. Substitute this back in here. 18. Just erase that. Theta is sine inverse. sine is x over 6. And cosine is that. Plus c. And then 6 and 6, that's 36, and yeah, so not much. We can simplify there, but that's what we have. Right. So note that here we have cosine square, which we use the power reducing, and so I put next to the power reducing this formula because that may come in handy when we have a double angle of sine. Right, so that's what we have on that one. Right. Next we have this. So let's see. First I write the x on the back, and now we have a variable square minus a constant square. So variable square minus a constant square. So that will be secant. Right, first let's put that on the back. The dx, that is on the back. And we want to write that as a square, so it's easy to know the substitution. So we write that 5x. That is the variable square for square dx. Right, now the substitution. We're going to let u, which is 5x, u, which is 5x, equal to 4 secant theta. Right, the variable equal to constant times secant. That's what the substitution is. Right, then we can take derivative here, or we can solve for x. So x is equal to 5 over 4 secant of theta, and derivative of secant is secant tangent. And move the d theta. Right, so we have dx and the substitution, right? I can just write here 1. X is 5 over 4 secant. So that will substitute for this x here. Yeah, that's what we get here. Right, next, the 5x, actually 4 secant, so I'm just going to use 4 secant instead of using that one. 5x is 4 secant. Square minus 4 square. Right, dx, wow, is this much. So I thought about that before. So 5 over 4 secant tangent d theta. Right. One. Right. Notice that the 5 over 4 here and 5 over 4 here does cancel out. The 5 4 and the 5 4 cancel out. So that tree is not as bad. Or we just multiply this reciprocal. Divide 5 4 is 4 over 5. 4 and 4 cancel. 5 and 5 cancel out. So either way they cancel out. 4 square and 4 square. 4 square, secant square, 4 square factor out. And then secant tangent. Now, of course we can see that also the secant cancel out here. Right. Next. The 4 secant square minus 1, that is tangent square. And then there's tangent. Right, cancel out. 4 tangent theta, tangent theta, d theta. Right. That conveniently cancel out. We just have 1 over 4. Take out the 4. And that's just d theta. So that gives us 1 over 4 theta plus c. And we need to solve for it. What is theta? So from, let's use this one. Or this one, doesn't matter. Secant is going to be 5x over 4. So theta will be secant inverse 5x over 4. Right, so that's what we have. Right, of course we can also go back and use this form where a is 4 and u is 5x. In that case we have to have 1 over 4. Right. Yep. That's what we have for that one. Next, this one. Once again, this one is a variable square minus a constant square. So that is secant. Right, let's rewrite this as x squared minus 6 square to the 5/2. Sorry, this will be dx. Right, substitution. 6 secant x be 6 secant of theta. So we take derivative is 6 secant tangent move to d theta. Right, let's see what we have. X squared at 6 secant theta square next x squared again 6 secant theta square minus 6 square to the 5/2 dx is that. Right, so dx and x square and then x square here. Right, so that's what we have. Now that would be 36, or if we just keep the power 6 square secant square right. So I have to pause the video to replace the ink because this is a little right. So that gives us 6 square. I can factor out the 6 square. Now secant square minus 1. All that to the 5/2. Then we still have 6 secant theta tangent theta d theta. Right. Secant square minus 1, that is tangent square tangent square to the 5/2. There will be 6 secant tangent d theta. Okay. 6 square secant square. The bottom 6 square to that, so we have power to another power, so we have 6 square to the 5/2. Multiply the power together, 2 times 5/2, so 6 to the 5th. Likewise, tangent to the 5th, 6 secant square, 6 secant tangent d theta. Let's simplify this. 1, there are 2 more here. Sorry, we cannot cancel like that. There's nothing at the bottom. Okay, sorry. We can only cancel the tangent. We do combine the secant square and secant. Right, but in terms of coefficient, 6 square and 6 and 6 to the 5th. So we have 6 square on the top and 6 on the top, 6 to the 5th at the bottom. So that's 1 over 36. Secant and secant, that's secant cube. Over tangent to the 4th. Alright, so what's that? So that is 1 over 36. Right. How do we simplify this? Of course, we can use this for tangent and secant. We can also change everything to sine, cosine. Secant is 1 over cosine. So the secant cube is 1 over cosine cube. And tangent is sine over cosine. And then reciprocal, so we cosine over sine. So cosine to the 4th. Right. Yeah, tangent over 4th is tangent to the 4th power is sine to the 4th over cosine to the 4th. Let me write this again in more details. Secant cube over tangent to the 4th. Secant is 1 over cosine cube. And here tangent is sine over cosine 4th. And multiply reciprocal. Cosine on the top, sine at the bottom. So we can cancel 3 of this. There's 1 left. Right. And then just 1 over sine to the 4th. And then there's a cosine left. Now this one is an obvious substitution. If we let u equal to sine, we have du there. Okay. I'm just going to write. Worry about the next problem later. Let u be sine of theta. So du is sine theta d theta. And derivative of sine is cosine. And move the d theta over. Usually I will solve for d theta, but Here we have du is equal to cosine theta d theta, which is exactly that. So this one, if we substitute, that will be just 1 over 36. 1 over sine, so that's u to the 4th power. And then all of that together is just du. Usually I solve for d theta. Now we just going to write du, and the integral of that u to the negative 4 is u to negative 3 over negative 3 plus c, and that is negative 108. U to negative 3, u is sine, so sine of theta to negative 3 plus c. The whole problem doesn't even fit on the one screen. Right, and finally we just need to solve for sine. This gives us secant is equal to x over 6, right? Which gives us cosine is 6 over x. Cosine adjacent over hypotenuse. So opposite would be x squared minus 6 squared. And sine is opposite over hypotenuse. So finally the answer is negative 1 over 108. And we have opposite over hypotenuse. Right, a little bit complicated, but that's what we have. Right, let's try this one. Actually, I think this is the tangent inverse. What's that? Yep. So that should be tangent inverse. Right, but let's do trig substitution. Instead, we have a constant square plus a variable square. What was that? Okay, here. Right, let's rewrite this as, hopefully we have enough space for that problem. Right, negative 1 to 1. 5. I'm going to write 5t square dt. Right, so we're going to let the variable 1 to 1 square, doesn't matter. We're going to let the variable equal to 1 tangent of theta, right? And then we can divide by the 5 over t equal to 1 over 5 tangent of theta. Then take derivative, dt over d theta is 1/5 secant square, and move the d theta. Right. Okay. Also change the limit. This one has the limit, but if we want to write the limit, for that we have to solve for theta, and later on we might solve for theta later, but for now just say that the limit here is for t. So be careful when we still, if we keep -1 and 1, just be mindful that it is still t. We do not change the limit because that involves in the inverse and other things. Five t is going to be tangent, so this is just tangent. dt is 1/5 secant square d theta. Right, 1/5 secant square d theta. Right, the 5 and 5 cancel here. Here we just have 1 on the top, and at the bottom 1 plus tangent square. And then we have secant square d theta. Right, 1 plus tangent square is secant square. Right, so that actually turned out extremely nice, and it's good that we don't have much space left here. So that just secant cancel secant, so that's just 1. We'll just have d theta left. Integral of that will be theta, which go from -1 to 1, which is the t is -1 to 1. Right. Now, what is theta? Well, tangent theta is 5t. So theta is tangent inverse of 5t. So tangent inverse of 5t, which go from -1 to 1. Now this is the values for t. So that gives us tangent inverse of 5 times t, which is 5. 5 times 1, which is 5, minus tangent inverse of -1 here times 5, so that's -5. Right, so yes, in gradient mode, tangent inverse of 5 minus tangent inverse of -5. So that's what we have. Now if we do that directly from the beginning, fraction yeah, we should get the same thing. Right, so that is that. Right, next we have partial fraction. So when we have partial fraction, is of course we have to factor the denominator, and from there we can decompose the fraction, and then we split. And for partial fraction, we don't have much formula, but just usually end up with something like that. So if it is a linear factor, that's what we have. If it is quadratic factor, we complete the square, so we can use that. Okay, so that will come in handy for sure. All right. Now let's look at the first one. Let's factor x squared plus ax plus 7. So x squared plus ax plus 7. Well, multiply to 7, we have 1 and 7, so that's pretty much x plus 1, x plus 7. If you multiply it out, that could be x squared plus ax plus 7. Right, so first we do the partial fraction. The partial fraction of 2x plus 32 over x squared plus ax plus 7. I'm going to use that instead. Now just a linear factor, so we know it's going to be 2x, just 2 factor. Right. To simplify, we multiply by the common denominator. So multiply by the least common denominator of x plus 1, x plus 7 on both sides. If we do that, x plus 1, x plus 7 cancelled out. With this, we have 2x plus 32. And this multiplied by x plus 1, x plus 7, x plus 1 cancel out, we have x plus 7. And this multiplied with that x plus 7 cancel out, we have x plus 1. Right, now the rest is we solve for a and b. So there's a lot of different ways to do that. Multiply them out, combine like terms. But the more direct way is we choose some values, so that will vanish. So if we cleverly choose x to be negative 7, that term will disappear, right? So we say when x equal to negative 7, I put negative 7 here for all the x's. Negative 7 plus 32 equal to a negative 7 plus 7 plus b negative 7 plus 1. Right, that go to 0. The right hand side is 32 minus 14, that's 18. Right, 32 minus 14.18. Yeah, and that gives us negative 7 plus 1, negative 6 b. So with that, b is negative 3. Right, now if we choose x to be negative 7, that's gone. If we choose x to be negative 1, this will go to 0. So usually when we have the linear factor, that will be very handy. If all of them are linear factor, that would be very handy. Negative 1 into x. Negative 1. Substitute into x. That one go to 0. 32 minus 2, 30. and that is 6a. So divide a is going to be 5. Right, so partial fraction, that's what we have here. So with that we can put it back in here. So the original integral I'm going to say x squared plus ax plus 7 as the factor form. So now we split into a is 5, and b is -3. Right here we can just split. Put a 5 here, and then 3, 1 over x plus 7 dx. Right, now that's just the formula over there, just ln of x plus 1 minus 3 ln of x plus 7 plus c. Right, that's simple enough. Right, next we have this one, x cubed plus 6x squared plus 9x. Let's factor that out first. Again, factor out an x, and then we have x squared plus 6x plus 9. Now this is x plus 3 times x plus 3. Right. Right, so let's do the partial fraction. Ax plus 36 over that, I just say x plus 3 square. First we have the factor of x, so just that. Now there are two factors of x plus 3, so we should have two factors of x plus 3. For repeated factor, that's what we do, and now the top will be just a constant and a constant. Right. Now multiply by the least common denominator of x times x plus 3. Square. Right, multiply everything by this one. That term that cancel out, we just have ax plus 36. And ax plus 3 cancel out completely. I'm sorry. Multiply that to that, x and x cancel out, we have a times x plus 3 square. And b. X plus 3, one of them cancel out. We have x and x plus 3. because one of the x plus 3 cancel out. And then c x plus 3 cancel out, we have c times x. Right. Now unlike this one, we have the repeated factor. So this one, if we choose x to be 3, of course though is gone, we can solve for c easily. If x equal to negative 3, negative 3, negative 24, 12, negative 3, so c is like 4 or negative 4. That's easy. If we choose x to be 0, those two will be 0. And so a is equal to 4. And finally, we choose some other value for x, we can solve for b. Right? But I just want to do that differently. And multiply them out and combine like terms. Right, this is x plus 3, x plus 3, multiply this out, bx squared 3bx, and then cx. Ax plus 36, a x squared plus 3x, that's 6x plus 9. By the way, x plus 3 squared is x squared plus 6x plus 9. I just choose that. Right, multiply out one more time. X squared 6ax 9a bx squared 3bx and cx. Combine like terms, x squared and x squared. And then ax, bx, and cx, all of them have x. Again, factor on x, 6a, 3b, and a c. And what's left is just 9a. Right, so that's what we have. Now, matching the coefficient. This polynomial equal to that polynomial only if the coefficients are the same. So here I can manufacturally make it 0x squared because there's no x squared here. So the x squared must match with the x squared. So a plus b, the coefficient, must match with the coefficient of 0. And the coefficient of x must match the coefficient of x. So 6a, 3b plus c equal to 8. And then constant 9a equal to 36. This one we can just solve by hand. So a is equal to 4. Substitute in here, b is equal to negative 4. And substitute in here, we can solve for c. Right. Right. Or if we want to solve that in the matrix form, because we don't need to know how to do this with the calculator. Right. 1a, 1b, no c equal to 0. Right. So the coefficient is a, b, c, and whatever on the other side. 6, 3, 1, 8, 9, 0, 0, 36. And let's do that reduce row echelon form. Right, second matrix, go to math, option B, and then we have the matrix, alpha zoom, 3 rows, 4 columns. Okay. One, don't hit enter here, just go next. 6, 3, 1, 8, 9, 8. Only hit enter when we're done. So A, B, and C. So it's not that bad. Let me show you how could we do this by hand. So first of all, the obvious here is that A is equal to -4. So the next one we can say we substitute -4 in here. Of course I substitute in there too, but yeah, one step at a time. And still have 6A plus 3B plus C equal to 8. Now we do know A is equal to -4. From here we can say that B must be equal to 4. I'm sorry, A here is positive 4. Sorry, 9A is 36, so A is 4. So 4, so B is -4. So we can substitute -4 and positive 4, -4 into here. We have 6 times A, which is 4, plus 3 times -4 plus C is equal to 8. So that 24 minus 12. So here C is -4. So it's not that bad to solve this by hand. Right, but that's what we have. So that means we split the integral as follows. So the integral of AX plus 36 we split into 3. A, which is 4 over X, so that ln easily, and then plus B is -4, X plus 3, that's another ln, and then -4, X plus 3, so that is a substitution. Right, we split this into 3. Let's write that. Okay. We split this into 3. 1 over x dx minus 4, 1 over x plus 3 dx minus 4, 1 over x plus 3 square dx. Right, so that is ln, ln of x, ln of x plus 3, and that is the substitution. It will let u be x plus 3 derivative is 1, so du is equal to dx. So substitute in here, we have -4 1 over u square. X plus 3 is u, and dx is du. So that's easy. For ln of x minus 4 ln of x plus 3 and u to negative 2, integral of that is 4 u to negative 1 over negative 1 plus c. And finally negative and negative cancel out, that plus 4, and u is x plus 3 to negative 1. Right, I've run out of space, but the next step is easy. Just simplify this and replace x plus 3 into u. Right. Right. One more. So for this one, again, factor the denominator. X cubed plus 9x. We can only factor out x, and then we have x cubed. So that will be x squared plus 9. So that is as far we can go, because we cannot factor x squared plus 9. So that's it. So let's do the partial fraction. Right. Here we have 6x squared plus x plus 45 over that. Which will be split into two fractions, over x and over x squared plus 9. So this is quadratic, so the top is going to be bx plus c. Power will be always less than the bottom. Right, multiply by the least common denominator of x times x squared plus 9. That cancel out. We have 6x squared plus x plus 45. And x cancel out. That gives us 8 x squared plus 9. And multiply this with this, x squared plus 9 cancel out. We have x times bx plus c. Right. I had to do it this way. Right. So we have ax squared plus 9a plus bx squared plus cx. It's not that bad. You can just do this by hand. Right, combine like terms. And there's only one term with x. And then one constant. Right, 6x squared plus x plus 45. Right now, matching the coefficient for x squared, a plus b must be 6. And cx must be x, so c is equal to 1. That's one obvious. And 9a is equal to 45. Right, so this one definitely we just solve by hand. A is equal to 5. And c is equal to 1. The only thing left to be solved for is b. 5 is a, so b is equal to 1. Right, so that integral is equal to a is 5 and bx, b is 1 and c is 1. Right, so that's what we have. Of course, we can split this integral in two, but further, actually, I will split in 3. You'll see why in a minute. Right. Here, I'm just going to write x over x squared plus 9, and then 1 over x squared plus 9. Now look at the formula we have. So the first one we have 1 over 5 over x, which is the ln. That's easy. Now this, okay, we'll talk about that later. 1 over x squared plus 9, so that we can use the tangent inverse. The formula's over there. This requires a substitution. Right, so let's just split this one more time. Five 1 over x dx yeah, we know this one's going to be tangent inverse, so let's write this as 3 square. This one substitution, so I'm not going to mess with that. So substitution, let u be x squared plus 9 du over dx is equal to 2x, so du is equal to x dx, so du over 2x is equal to dx. Okay, that's the substitution for that one. First, integral 1 over x is just ln of absolute value of x. This will have x squared plus 9, that's going to be u, and dx is du over 2x. And this is the formula 1 over a, so 1 over 3 tangent inverse of x over a, x over 3 plus c. Right, x and x cancel out, the 2 take it outside. 1/2, and 1 over u, integral 1 over u is ln of absolute value of u plus 1/3 tangent inverse of x over 3 plus c, 5 ln of x, 1/2, u is x squared plus 9. By the way, x squared plus 9 is positive. We really don't need the absolute values. It's not wrong to write absolute values, but even better, just use the parentheses. Just so that we know that's positive. Right. So, even though we only split this problem into two two fractions, but in order to integrate, we want to split that because this requires substitution and this requires just trig substitution. That turned into a tangent inverse, and that turned into a substitution problem. So that's what we have. On this one, well, one thing for sure, it's not iteration by parts, no trig substitution, and we don't have the square to do that, so that's not trig substitution, not trigonometry. So the only thing left we can do is just regular substitution. Now, let's just write out what can we say about this. There's a few options. If we let u be 6e to the x plus 2, derivative is going to be 6e to the x. And by the way, e to the 2x here can be written as e to the 2 times x, or x times 2 if you will, which gives us e to the x squared. Right, so how did that help? It will help because when we take derivative, e to the x will cancel with e to the x, but still at the end we still have e to the x. But actually just make a similar substitution like this. If you only let u equal to e to the x, that will cancel with that. Because regardless, whether we let u equal to 6x, 6e to the x plus 2 or e to the x, we will never cancel with e to the x squared on the top completely. So in that case, just make it e to the x, so we might find out something later. Alright, so that is the case. We check derivative. Same thing, move the dx. And divide by e to the x. So this will be just routine type. Right, now. Right. That we can write as e to the x squared or u squared if we want to. But, okay. Yeah, if we want to, we can write everything in terms of u. Okay, that's will work. Okay, e to the x here, that is u, right? And then 6, e to the x again is u. And dx is du over e to the x. Right, if we write e to the x, of course that by itself, but we also know that e to the x is u, so we replace that by u. Then we can cancel with this u. Now cancel. Right, now this is not partial fraction because we only have one fraction, and besides partial fraction, usually the power on the top is less than the bottom. Here they are equal, so there must be something else. So actually what we do here is another substitution. Now if we let u 6u plus 2 equal to v, then we check derivative. Move the du. and then solve for dv. Solve for du, sorry. Right, so that equal to u 6u plus 2, so that is v, and dv over 6 is du. Okay. Here we can take out the 6. Right. Now there is a problem. The problem here is integral in terms of v, and we're left with u. Luckily, it's not that bad. From here, we can just solve for u easily. So subtract 2 on both sides. We have v minus 2 is equal to 6u. Divide over, so we have u is equal to v minus 2 divided by 6 is equal to u. Then we can substitute into that u. Right. Divide fraction is multiply reciprocal. Right, also take this 6 outside. 1 over 36. Right, 6 times 6. And then we have v minus 2 over v dv. But the last one will be easy. I will split this into v over v minus 2 over v. So that gives us 1 over 36 integral of 1 minus 2 over v dv. Right, I will continue that from here. One over 36 integral of 1 with respect to v, it's just v, and 2 over v is 2 ln of absolute values of v. Sorry, wrong sheet. Okay, that's what we have. Integral of 1 is v, integral of 2 over v is 2 ln of v. Right. Now, v is, what's v? Okay, 6u plus 2. That is v, and then u is e to the x. Substitute that back in here. 1 over 36 6e to the x plus 2 u is e to the x minus 2 ln of 6 e to the x plus 2 plus c. Right. So that's what we have for that problem. I think I stop here and then pick it up on another video.